Good evening, everybody. We'll get started. It's 6:05. Once again, I want to welcome everybody to our soil sampling meeting. We have our speaker, Mark Turner, from On-Scene Coordinator and Response Coordinator for EPA, provide a presentation, and then we'll have a little time for some question and answers. And we'll have a few instruments over here and equipment. After the meeting's over, if somebody has some questions about it, please feel free to stop by and speak to them after the meeting's over. So once again, I wanted to thank the church, the First United Presbyterian Church, for inviting us and welcoming us, giving us this beautiful building for this facility. And once again, if anybody needs some restrooms, they're over there. With that, I'd like to introduce Mr. Durner, Mark Durner, and welcome everybody once again. Thank you.
Thanks, Adrian. Can you guys hear me okay? I don't want to stick this in all the way up to my face because it's really loud. So yeah, no, I appreciate you all coming out. It's a beautiful night, and I think we'd all rather be outside, hitting the walking trail or doing something. But I really appreciate you coming out. We're at a point with the soil sampling program where we are now getting validated analytical results in. We've had a lot of preliminary results in for 3 or 4 weeks, but we really can't talk about those results until they validate and make sure they're legitimate data points. Now that they are, we are in the process of calling residents who gave us access to the properties to collect samples on their land and letting them know what those results look like. In the next couple weeks, they'll be getting hard copies of this. So if any of you actually had samples collected on your property, not in the public right-of-way on the edge, but actually on your property, you'll probably be getting a call from us soon. About 20 to 25 of the 50 people who have allowed us to sample on their property so far, we've got the results in, and we've been making those phone calls. So with that, the first thing I'm going to do is kind of talk about, let you know kind of the bottom line up front. Oh, hey, Linda. The key here is that we finished the field work for the first phase of this soil sampling program. That's done. Now, it's also important to note, again, just giving you the bottom line up front here, is that we are planning most likely to take on a second phase of sampling. And you'll hear why as we kind of get into the meat of what we've determined so far in kind of an interim basis here. Also, some of the lessons that we learned from you, talking with some of you. I just had a conversation earlier with a gentleman that we were talking about some areas that we may want to investigate a little bit further as well. So what we did so far isn't the end of the road, but it does inform us on a lot of needed data to help us make decisions moving forward. So one of the important things to recognize is that smoke plume, covered a really large geographic area, and the modeling that we did drove how we determined where we're going to sample. You'll see this figure in one of the slides here in a few minutes. But this was the area, in this area and a little bit further downwind, was the most heavily impacted area. It wasn't the only impacted area. You all know that because you lived it. You know that before the vent and burn operation that there was smoke swirling all over the city. And that's one of the reasons that we chose this 1 mile radius around the derailment site. You also know that the wind shifted. It wasn't just that area to the southeast into Pennsylvania that was affected. It was also areas up north. It shifted and moved straight north. So we know that there was a very large geographic area impacted. The modeling also tells us, we had one of our national laboratories evaluate the burn in worst case scenario, and the modeling told us that the concentration of particles in the air that would have deposited on the ground was about 0.1. So if those of you that were in the smoke plume, you probably noticed a very fine particle, very fine dust that landed on your properties. You may have also noticed some chips that may have landed on your properties, which I'll show you a few pictures of here in a few minutes. So knowing that we didn't have heavy soot, but we did have very fine particles, it was important for us to target this first round of sampling to try and find worst case conditions. So the next key message is that from the soil sample results that we've received to date, the preliminary results that we have, and the validated results that we have. Most of the data is within typical ranges for the compounds that we were looking for. In other words, we're not seeing an increase in concentration from what we expect to see in area soils. But that's not the whole story. There were some outliers, and I want to make sure that we let you know where we are seeing some areas that we may want to investigate further, because it wasn't all within those typical ranges. There was some data that was outside of those ranges. One of the important aspects of this, and we'll explain it later, is that we didn't see a difference between the shallow soil, where the particles we would still expect those to exist, in the deeper soil. Every sample location had 2 samples collected, one shallow and one deep. And we'll explain that a little bit more here in a few minutes. And then anybody who gave us access to the properties, the good news is that on your property, the soil sampling results looks really good. Right around those residential screening levels, which we'll explain in a minute. And also, the shallow soils look consistent with the deeper soils, and the levels are really low. However, there are a few of the right-of-way samples, like I mentioned. They came back with higher levels. Those are right next to the roadways, and we think we understand why that's happened in a few of those locations. The vast majority of those samples were just as low as the on-property samples, but there were a few outliers. So we'll explain what that means here in a minute as well. So, as I've sort of explained, this was a comparison study. We wanted to figure out what the area in the most likely impacted area zone was compared to the background. Now, I know you can't see it on this figure, but there's a bunch of green dots out here in the background. This is the area that was not impacted by smoke. It was outside of the downtown area that had the swirling winds early on, and it was not impacted by the vent and burn operation. We also collected some background samples over in Pennsylvania as a double check. We used the same methods for sampling in the background that we used in the area of interest. We biased or targeted every sample we collected towards areas that we thought we looked for evidence of soot or ash at every location. What we've heard was it's pretty impossible to find soot or ash 3 to 4 weeks after the derailment site, right? I mean, that's common sense. We agree, again, especially after I explained how fine those particles are. But to our surprise, it was actually a worthwhile effort, because we did find some discolored soil where we would target some samples. We did find some of those chips, which we'll show you a picture of here in a minute. So we did see some areas that targeted our samples towards worst case scenarios. So it was a fruitful effort to do that. Secondly, again, as I mentioned before, we targeted the area that our model suggested we'd have issues. Now, the model also told us what other compounds we could expect to see. Those that may have been impacted, especially downwind, by the smoke plume and had some mild respiratory distress, there's a chance you were exposed to hydrogen chloride. That's a common contaminant with this type of compound when it burns. Very low levels. The modeling suggested that that it wouldn't create significant health effects, but it could be an irritant. So if you did experience issues like that in the smoke plume, that could be a potential cause for that irritation. In addition to that, the modeling also told us that we would not expect to see a high concentration of dioxin compounds, which is the compound that most people have indicated to us that they're concerned about. The primary contaminant that we're looking for are semi-volatile organics, which are common products we would see from a burn. Dioxins, we wouldn't expect to see that, but there was enough interest in that particular chemical that we added that to our soil sampling list. Important to note, we were comparing, again, that top inch of soil to the deeper soils. The analytical results are showing us, as I mentioned earlier, that the top inch and the lower 5 inches are the same concentrations. That indicates to us that where we see contamination, it's probably legacy contamination from our industrial history here in the U.S. We evaluated a variety of property types: agricultural, residential, commercial. And then at the end, we added recreational. The city indicated to us that people are going to be using the park soon. People are going to be using the ball field soon. Even though some of these locations were outside of our area of interest, they asked us to do some rapid assessment to determine if those areas were impacted. You probably note, if you've been following us closely, that we released the data from City Park. That was the very first thing we sampled. We got that data back fast, prioritized that validation analytical, and released that data. And that data was also reviewed by an independent contractor that the city's using to give better assurance that the data was good. The most important thing we need to emphasize about the work that we did over the last month was this was not a risk assessment. And so what does that mean? A risk assessment would be looking at exposure pathways. How are you going to potentially come into contact with these compounds, with these chemicals? The study that we did was to evaluate whether or not the background areas and the area of interest were different. Do we see a noticeable difference between those areas? Does it indicate to us that we have an obvious deposition problem from these compounds? If we were doing a risk assessment, we would look at every individual property discretely and say, okay, where are sensitive populations more likely to access? Where are kids going to be playing? What are common pathways or walkways where we might track soil into the home? Then we would set up some type of grid system and collect samples like that. That wasn't done here. This was a very targeted investigation to determine whether or not area background and our target areas were consistent. So just understand that. If we ever get into a phase where we do need to do some risk assessment work, the sampling protocols will look a lot different. So just wanted to make sure that you understood that. So I mentioned we're sampling for semi-volatile organics and dioxins or furans. So when I say dioxins, I mean dioxins and furans. I mentioned that the semi-volatile organics are indicator chemicals for the vent and burn. They're common to the environment. You'll see some semi-volatiles in just about every sample you collect. Very low levels, but they are very common to the environment. Sources, as you can see on the slide, include mostly oil-based products. Any petroleum site we work on, we see high levels of SVOCs or polyaromatic hydrocarbons. That's another word for them. They're used in a number of industrial and household chemicals as well, as you can see on the list. Then there's the dioxins. Again, we sampled for dioxins because you told your elected officials we want this compound tested for. So we added it to our analyte list. Like SVOCs, dioxins are very common to the environment. So I'll give you a little fun fact about dioxins. In rural areas, we were looking at background studies to try and figure out what are typical ranges for dioxins in the environment. And the state that had the highest level of dioxin contamination in rural areas, based on our background studies, was Hawaii. Any guess why? Volcanoes. All right, you win the prize. Yeah, volcanoes. Volcanic activity creates, it's basically, subsurface fires get to the air, and that ash deposits. That ash leaves a legacy contamination for dioxins. So Hawaii has the largest rural dioxin contamination issues, natural dioxin in the world, or at least in the United States, based on the literature review we did. So again, it's common. Anything we burn likely creates some levels of dioxin. Barbecuing meats creates low levels of dioxins. Dioxins are common in our environment. Burn pits, forest fires, smoking, all create exposure to dioxin contaminants. So it's common. And again, you can see on the list, car exhaust, industrial byproducts. When we do the dioxin calculation, you'll see on the analysis list, and we'll show you that in a minute as well, you'll see a number of different compounds that are in the family of dioxins. We do a calculation to give you one number of what we call the toxic equivalency for dioxin. That number is never going to be zero. And the reason is we have a reporting limit, so the analytical devices can only go so low. They get well below our screening levels, but they can only go so low. And so the way we calculate that toxic equivalency is we divide that number in half, and we add them all up against the compounds if we have non-detects, and we assign it a number. So it's never going to be zero. Every sample result you ever see for dioxin TEQ will always have a number associated with it. So you'll never see zero there. You'll never see non-detect. So just a little background about dioxins. So then we compare all this analytical work we're doing, all this laboratory work we're doing, we compare it to what we call residential screening levels. It's important to understand what those are. Those are the lowest risk levels that we would expect to use to call, if we're below that level, to call something safe. And so that means it's extremely conservative. Think about it this way. If I'm standing in soil that has dioxin compounds in it, and it's at a certain level, and I'm exposed to it 365 days a year, 24 hours a day, then that equates to a risk number, all right? So that lowest level that we use, and you'll see the number on the next slide, it's 4.8 parts per trillion. That's the lowest risk level. That means I need to be exposed to that 365 days, 24 hours a day, right? That's not real exposure. That's theoretical exposure. When we do a risk calculation for a project, we're going to take in all these different factors. We have a site, a big dioxin site up in Michigan right now where the cleanup level, the risk level, is 250 parts per trillion. Now, that's based on several risk factors. We're comparing to the lowest risk factor, 4.8, because we wanted to make sure that our analytical devices, the laboratory equipment, could detect below that level. So we can give you the lowest possible data to share, to compare it with all of our risk levels. As I show you some of this information, we're going to talk about everything in parts per trillion, okay? Just for ease of reading. So when I say 4.8, I mean 4.8 parts per trillion. On the lab sheets, you're going to see those referenced in parts per million or milligrams per kilogram. And that means for the dioxins, there's a decimal point and a bunch of zeros before you see the number. For the semi-volatile organics, you're going to see the number in what looks a little bit more normalized, like you're going to see tonight for the dioxin number. So I just want to let you know that there's orders of magnitudes between those numbers. Everything we're going to talk about tonight is parts per trillion. So again, I need to emphasize this, that what we did in this study was not a risk assessment. This was a comparative study between area background, and the zone of interest. But it's important to just get some context to what these numbers mean. So if you can see the red dot, we're looking at these TEQ values, which I just expressed. Our lowest cancer risk number is 4.8 parts per trillion. And again, that assumes you're exposed to it all the time. You're breathing that dust all the time. Our lowest non-cancer risk level is 51 parts per trillion. And again, that means you're exposed to all the time. It could create health issues if it's a continuous chronic exposure. By comparison, I work in a program called the removal program, which is we have to get this waste, we have to get this material out we have to initiate the cleanup within 6 months because of the exposure concerns. Those levels, if we were in that ballpark, is 10 times that number, 100 times that number, I'm sorry, 480 parts per trillion. And for non-cancer, it's 3 times, 150 parts per trillion. So it's a lot higher. Because we know we're going to get in there, we're going to dig that contamination out and backfill it with clean soil within a very short period of time. So we can tolerate a higher amount of this material in the short term. Historically, EPA's action level was 1,000 parts per trillion, but that was back when our analytical techniques weren't as good. That was back when we didn't know as much about the different risk factors. So we've adjusted those risk factors, as you can see from the numbers above that. And then in levels in rural soil, we expect to see it up to around 20 parts per trillion. I mentioned Hawaii. Remember, it's up around 27 to 30. Those are just guesstimates based on our literature review. We're going to refine those numbers as we get into this further. There's so many background studies out there that we're just giving you an estimate of what those numbers will probably come in at. But in urban soils, here in the city, we would expect numbers to be up around no more than 60 as background, and no more than 20 out in the rural areas. And quite frankly, the data that we're seeing in the rural areas are so much lower. We're seeing it down around 3 to 10, much lower than that 20 number. You've seen this, this image many times. No, I'm not going to go through that anymore. Here's the process for sampling. First, we do an inspection. Guys, stand on up. I want to introduce you to a few of our, Eric, you stand up too. So Eric's one of our on-scene coordinators out of our Cleveland office. He and I both work out of Cleveland. These are our technical support contractors. You're out of Pittsburgh, right?
Yeah, my name's Connor Martin. I'm out of Pittsburgh.
Connor, and?
My name's Oriana, Chicago.
Great. So thanks for being here, guys. So these folks would walk the properties. Every property we walked, we would do a full inspection. We would actually, once you guys explain the inspection process and then the sampling process.
Sure. So when we would get to a property, we'd walk the property, doing a visual inspection. We would walk across the property, looking for any signs of ash or the metal flakes that we saw in some areas. And certain areas we collected samples, others we did not. And when we did collect the sample, we would put on gloves, clean gloves for each sample, and then we would either use a sterile scoop, so the gloves, sterile scoop, if the soil was soft enough to take that. We also had metal spades with us, which we would decontaminate between every sample collected. And then we would fill our jars to send to the labs. So we have clear jars, which we'd analyze for semi-volatile organic compounds. And we have the amber jars, which we would collect soil to be analyzed for dioxins and furans. Amber because dioxins, furans can break down in sunlight, so we want to help stop that process once we collect the sample. And then once we collect that sample, we screen the soil with air monitoring equipment. So this is a multi-ray device. We're using the PID or photoionizing detector in it to look for volatile organic compounds in the air. This is a screening tool to kind of give us a sneak peek, if you will, of what the lab might tell us later. This isn't definitive, it's just to kind of see what we're dealing with when we're collecting the sample, and it might match up with what the lab finds once they analyze it. Once we get the jars, the soil in the jars, we'll document everything, write the ID, sample time, document it on this chain of custody, which the custodian has to sign when they pack it in the cooler, and then the lab will sign when they receive it to ensure custody throughout the process. And we'll pack all of that up in the cooler. We'll keep it less than 6 degrees Celsius, which is standard preservation when you're looking for semi-volatile organic compounds and dioxins, furans. And we'll ship that sample for analysis by the lab, and then that data is what eventually comes back to the EPA, gets verified, and then that's the data that Mark is talking about today.
Thanks, guys. So again, you can see the actual physical sampling on the screen above. And thanks to Eric. He was our first responder on scene the night of the derailment in the middle of the night. So appreciate your efforts, Eric. Those chips we talked about, the scale, if you will, we believe that was scale from rail cars. We don't know that for sure. But the next image I'll show you will kind of give you an idea that it probably was, right? You can see in the upper right-hand corner what that scale looks like, or in an envelope on the bottom what that scale looks like. Again, that's what we believe it was. And so when we would collect a sample from that material, we would include that in the sample, along with those shallow soils. Interestingly enough, just about all the samples that came back with this material in it came back at extremely low levels. The hits that we saw that are a little bit higher, that I'm going to talk about here in a few minutes, those weren't associated with the scale, which I found interesting. I expected to see higher, especially higher semi-volatile organics where we had this evidence, but we didn't. So all the red dots you see on that screen, and it matches up with this image, which we'll show you in a minute. All those red dots are where we found ash, not ash, those chips. So that's, that just tells you, it follows that pattern, that wind pattern, that modeled pattern that we expect, that we saw, that we observed on scene, and that we also observed through the modeling efforts that were done. So quick by the numbers, if you will. 358 sites were inspected. 148 sample locations. Now, these weren't 148 separate properties. We had some properties where we had multiple locations. For example, City Park. We had 7. City Park was more like a real risk assessment. We did several samples in areas where we knew individuals were going to be occupying the locations. So that City Park's more of an indicative of a real risk assessment. And that'll be significant when you see these numbers I'll show you later. Each sample had each location had 2 samples, one shallow, one deep, as we mentioned before. Norfolk Southern's contractor, Arcadis, collected samples at every single location under our direct oversight. We oversaw every sample that was collected. And we split 20%, as our team here just told you about. We collected 20% samples, sent them to independent labs, and we'll match our data up against the railroad's data to make sure that we can confirm the quality of their data. Now, as far as the railroad goes, the lab they're using is called Eurofins. They're a very highly reputable lab in the U.S., so I'm not concerned about their choice of laboratories. We're also using a reputable lab. I think we're using PACE, right? Labs out of Pittsburgh and Minneapolis. So yeah, the laboratory quality is high. And then also, just to make you aware, our partners in Pennsylvania, the Pennsylvania Department of Environmental Protection, in coordination with EPA, are collecting several other samples further out in these areas of interest. So there's going to be even more data coming your way from Pennsylvania. They're doing very similar sampling activities that we're doing. So again, you can't have enough data to make decisions with. This is the results table. A graphic. You can come up and look at it after we're done here. But you can see on the outside, we have all these background samples. A lot more background samples than you see on this image. We directed Norfolk Southern to collect a lot more samples for various reasons. We wanted some recreational properties assessed to make sure that they were safe to occupy. We wanted some, working with ODA and the Farm Bureau and their partners, we targeted some agricultural properties a lot further out to give the agricultural community more confidence that their plants and crops would be safe. And then we also added some background samples in Pennsylvania. In addition to that, we also added 10 more locations further to the southeast in Pennsylvania, because when we looked at the model, we realized that the heaviest deposition area was actually a little further out, a little further downwind than closer to the derailment site. So we amended this plan midstream to go further out and collect more samples. So again, we wanted to get the best coverage possible, but we wanted to do it quickly. That's why this was very focused. The analysis, again, semi-volatile organics, dioxins and furans. The only point I want to make here is that if you look at the semi-volatile organics, when you look at those lab sheets, you're going to scratch your head a little bit, right? You're going to be like, all right, why are some of these compounds down around 0.78 and other RSLs up around 5,900 parts per million? Well, that's mainly because the toxicity of these compounds are all over the board. All right, so you'll see when you look at the tables online, you'll just see a wide variety of different screening levels. That's okay. We're also comparing it to background levels, and again, just like the screening levels, the typical soil levels for semi-volatiles are all over the board as well. They're very variable. The dioxins and furans, the dioxins get the most attention. We have pretty straightforward numbers once we do that toxic equivalency calculation that we explained earlier. 4.8 is at RSL, and then again, we have some typical soil levels that are just really rough estimates. I really didn't want to put those rough estimates out like this because we do pretty thorough literature reviews, but I also didn't want to hold back information. So that's why we went ahead and threw those estimated numbers up there for you, just so you could kind of understand what we're looking at. and what levels we may take additional action on in terms of follow-up assessment work. So how to review a data table, it's pretty straightforward if you know what you're looking at. The problem is most of us don't know what we're looking at when we do this. But the analyte, the compound that we're looking at, you'll see total dioxins and furans, then you'll see all the semi-volatile organics. Then beneath the semi-volatile organics, you'll see all the what we call congeners of dioxins. The congeners are used in the total calculation. And remember how I told you that we're talking in parts per trillion? That 4.8 is actually 4.8 with 5 zeros in front of it. So it's a really, really low number. And again, that's because of the potential cancer effects with this compound. That's why the screening levels and those action levels are so low. And then you can see the results as it's compared. Now, on these data tables, we will go ahead and shade every compound that is above the screening level, because you'll see a lot. They're not much above the screening level, and they do fall in, most of it will fall into those typical soil ranges, but we will shade them for ease of looking at these data tables. And you'll see a few of the semi-volatile organics that are slightly above screening levels as well, and they'll be shaded as well. So again, when you look at these online, and we should have these online by early next week or so, so look for it soon. But I just wanted to give you an idea. Now, when you see a J after the value, that's an estimate. That means it's really close to the reporting limit, and it could be, like in that case, it could be 0.24 or it could be 0.26. It's going to be really close to that number, but the laboratory technician flags it as an estimate because they can't give you an exact number. It's basically a rounding error. If you see a U, that means undetected, and then there will be some other qualifiers with the data that we will have explained on the data sheets when you see them online. So that's how you look at a data sheet. A couple of last quick notes for you. I'm sure you're all interested in seeing numbers, right? What are we seeing? On properties where people give us access and we go out into the properties and collect samples, not on the public right-of-way, but actually on property. Even though we're looking for worst-case scenarios where we think contamination may be, of the 20 to 24 properties we have validated data in for, only we're seeing really low levels, 2.6 to 14 parts per trillion, again, which is well within that range, right, that we were looking at. And we only had one detection over 8 parts per trillion for that dioxin TEQ. So it's, again, the numbers are right where we would expect them to be. So we're on property, limited number of samples, and mind you, and some of those samples are in the background, some of them are in the zone. But right now, we're not seeing anything that compels us to take action. However, in the public right-of-way, we are seeing some outliers. Now, the vast majority of the preliminary and validated data that we're seeing is very low. It's within those typical soil ranges that we talked about. But we had 3 pretty key outliers, greater than 100 parts per trillion. That's significant. Again, you saw those different action levels. If this were a risk assessment and we were using those action levels, this is something that would, give us pause. And because we have a few of those outliers, now, again, they're all on right-of-ways, right next to roadways. They're not in areas that kids play and so forth. But they're there. And so that will motivate us probably to do some more assessment work. Once we get all the data in, we apply statistics to it, and we analyze, we do some heat maps and so forth. We'll probably take some additional assessment steps to figure out what this means, okay? So not all the data looks great. Just about all the data does look good, but there are a few outliers there. And then there are some higher outliers within those ranges that we talked about. Probably another 6 or 7 samples came back on the higher end of those normal soil ranges. We may take an additional look at those areas as well. The SVOC results on property and in the public right-of-way looked very similar to the dioxin results. But the dioxin, because it's one number, it's easier to kind of digest, if you will. The average dioxin number that we saw was 17.9, but if you take out those couple outliers, it drops all the way down to 7.7. Okay, so that's how significant those couple outliers are when you're interpreting the data. But we look at the median. Half are above that number and half are below that number. It's down below that residential screening level, 4.5 parts per trillion. That's pretty significant to us. Now, again, this is preliminary data. So I don't want to get too excited about that number, but and we still have some other sample results to get in, but we're encouraged by that number. And then just by comparison, City Park, all those numbers came back below that screening level. City Park was at 3.3 parts per trillion, really low. Again, we don't typically use the word completely safe. We always talk in degrees of risk, but this this gives me no concern whatsoever. So, okay. Some community outreach. What are we doing to inform the community? We're doing this, right? Public information side. We will continue to update the website. We will continue to get the word out in forums like this moving forward. If you have any questions, drop by our Welcome Center. If you want to talk to a technical person, you can drop by the Welcome Center and make an appointment. When I can, I'm happy to come down and have conversations with you myself. I'm happy to get some of our really smart people, because I'm not that guy. I'm happy to get some of the really smart people here to talk numbers with you if you're interested in that. Those who signed access agreements, we are calling you with your data. If you had your property sampled and you haven't gotten a call yet, that means we don't have your validated data in yet, but it's coming soon. The hard copy tables will follow with additional information, how to read those tables like I kind of explained, and more information. This is just a copy of slide 1, again, just to reiterate. Done with the field sampling in phase 1. Most of our preliminary data is in. The vast majority of our results are typical soil ranges. We're not seeing a noticeable difference between the top inch of soil and the 5 inches of soil below it. The property where we got access and we actually went onto the property, those data look great. Some of the right-of-way compounds are elevated, but the vast majority of those samples also look good. So we're encouraged, but we recognize we still have a lot of analysis to do. Next steps: receive and validate all of our data. Post that data for your review so the public can see it. We're going to conduct those statistical analyses on the data and then work on that interpretation phase. We'll report our findings. It might be a simple letter report. We will get a report from Norfolk Southern's contractor, but we will also provide our own analysis of the data. And then we'll develop a phase 2 sampling plan. Now, because we have those couple outliers, I can't see any way that we wouldn't engage on another sampling program. That would be irresponsible of us not to do it. So I don't see a scenario where we don't do some more sampling. So stay tuned to see what that looks like. And again, we may augment some of the locations that we sample based on some of the feedback we've heard from you. And we'll certainly look at those outlier samples. We expect, because they're next to roadways and a lot of contamination comes off roadways, it's probably due to just influence from the roadway, but we don't know. We don't know unless we look. So that's important too. So with that, talked for a long time, but it was a lot of important information to share. So we got time for questions, and we'll stick around as long as you want to have some more conversations. So let's do it this way. Somebody want to man the mic? There you go. He was
Any questions back there?
This gentleman right here, Adrian, right in front.
Just to be clear on you called it the right-of-way, where you had the higher.
Yeah.
That's what you're talking about when you said
Yes.
most of the higher ones were.
Yes, within the first few feet of the road.
Of the railroad, correct?
Oh, no. Good clarification. I'm glad you said that. No, this was on the right-of-way of road. So if, just to give you an example, so the railroad's down here, right? This would be a right-of-way. I know we had one sample out here. It's kind of in the middle of nowhere on a road that was through a forested area. I think that was one of our locations. So it's on the right-of-way of a public street. Okay, so yeah, so the 3 locations, actually all 3 locations were on the Pennsylvania side, and they were all along highways. Yeah, you're welcome.
When you were talking about testing for the different chemicals, and you were talking about that limit,
Yeah.
Is there any studies when you're exposed to that many chemicals at lower limits? That was my first question. And my other question is, when you kept talking about the modeling, is that the modeling that you did for just the one car?
No, we did, so you asked two questions here. So let's start with the first question. When we do a risk assessment, you're absolutely right. When we have multiple chemicals that are involved and we assess risk, we take that, the risk assessors, and again, they're much smarter people than me, they take all of that risk-based data and they put it into a calculation, and the numbers are going to come out a lot lower than, let's go with that. Remember that I told you there's a removal level of 480 for dioxin? But if it's dioxin plus 5 or 6 known chemicals and in certain concentrations, that dioxin number might drop down to 50. Or that 4.8 might become the dioxin level that's accepted in that risk calculation because of potential exposure to other chemicals. That's a risk assessment? No, again, this sampling program was not a risk-based sampling program. This was an investigative sampling program to determine if the area in here and the background areas were similar, okay? And then once we get all that data analyzed, we'll have a better understanding of that. But risk is based on an individual property, not in a broad context like this. Does that make sense? Sorta?
So you guys didn't, the numbers you guys used, you guys didn't calculate for all the different chemicals together? You only do that with a risk assessment?
So
You guys didn't do a risk assessment?
we did not do a risk assessment for this, no. So that's an important distinction. So thank you for clarifying that. No, this was strictly to investigate whether or not the area within the area of interest was similar or not to the background. Okay, that was the purpose of this. A second phase of this may include some risk calculations if we determine that's necessary. So.
I have a question about the banks over there where the creek's running through the park. There's the bank
Okay.
coming
Yes,
up into the entrance of the park.
Yeah.
There's still visible chemicals coming out of the soil. I seen where the testing was done in 7 different areas, and none of the testing was done where people walk up into the park along that creek or eat over at the diner, you know, over at the thing. Is there going to be any testing with these banks of the creek going into the park, for number one? The second part is you know, there's people dying or getting their test results back from their urine with vinyl chloride. At some levels, we've done 13 different chemists and toxicologists. Some of them are ranging really high. For people say about smoking, people say about shampoos, deodorants. You would have to smoke 20 packs of cigarettes a day for the levels that some of these testings are coming back. Do you know where these are coming from as far as the tracks being dug up? I know this one side's complete. They're going to come up the other side with the rain. You said in before it hit 7 feet, it hit clay. Is it going to disperse back into the stuff that they just cleaned up? How is this all working out?
So there are a lot of questions in there. Yeah. No, it's okay. No, we can attack them one at a time. So the first one was, is there going to be sampling on the stream banks or around the streams down in that area? So we currently have an administrative order with Norfolk Southern, and that directs them to develop work plans for all of these components of the cleanup. One of those components is the stream assessment program, right? Sulphur Run, Leslie Run, all the way down into Little Beaver Creek. Am I saying that right? Little Beaver Creek. And so we have not approved that plan yet. They've submitted the plan. We've kicked it back with a ton of comments. That's not approved yet. So eventually, yes, those.
How can they say that the park's safe if there's still chemicals in the banks?
So we are, no, I understand that, and that's a great point. Our recommendation still, and we know that the creek is posted, do not enter. Our recommendation is not to access the creeks. Stay away from the derailment site, stay away from the creeks. They're still contaminated. We know that, heavily contaminated.
Even if it's raining or the dew in the morning, it's still there.
So, yeah. So that gets to your second question. Now, unfortunately, I'm not a public health expert, so it's really hard for me. I don't like getting out of my technical comfort zone, if you will, to talk about those issues. So, the only thing I can tell you about the biological testing that you guys made me aware of it at the last town hall that we talked about.
2 months later, I was tested positive.
I understand. And, there is now the longer-term clinic open, and from what I understand, is they do have toxicologist expertise associated with that clinic. So I guess my best advice right now is to utilize that resource. If there is a correlation between the derailment and, what's happening in terms of public health, we need to, we're working to try and figure out if there's a connection there. So, yeah. And then your third question,
With you guys hitting clay and it
Oh,
being
yeah.
raining and stuff like that, this stuff leaching back into
Yeah.
our-
So you guys asked me that question last time, and I had a whole list of, because we haven't had a public meeting since then, I had a whole list of questions that we took back to our operations teams, and that was one of them. And what they've done is they have developed a water management system where even when it rains, they are able to keep up with the water in the trenches, where you shouldn't have any crossover contamination, because they are keeping that thing pumped dry. As you know, they're starting on the north side. That excavation is starting. If they do have any bleed over, we should be able to see it. We're going to be overseeing that operation. I believe so. I don't have the exact answer for you. I believe so. I'll have to check with our ops guys to give you the complete answer. So, yeah. Question here. Then Linda had a question. Either or.
Hey, Mark.
Hi.
Hi. Okay, so again, like everybody else said, I'm not a chemist either, not a specialist at all. Dioxins, lots of different ones out there. Obviously, common one that we know of that will kind of raise eyebrows is the TCDD, which was the herbicide Agent Orange. What type of dioxins are we talking about here? And do we even know, because this is a chemical cocktail that is new to everyone, so do we know what we're looking at, and are you testing for them, and can you even test for them accurately at this point?
So the answer is yes. So if you go in and look at the city park data, you'll see all the different dioxin congeners that we're looking at. We're looking at the congeners from TCDD, which you mentioned, all the way down through the OCDDs. Those are just acronyms for words I can't even say. The TCDD is the one that's that has the highest toxicity value, and we see a couple outliers. We're seeing TCDD in those compounds. One of the OCDD compounds is more typically associated with burning, and we are seeing that as one of the primary drivers in the data. Now, again, we're just getting into the process of digging into the data and the numbers, but right now it's looking pretty consistent. This is an old coal burning area, right? So it's not surprising to us that the legacy dioxins that we're seeing at depth have a high concentration of the OCDD. But again, in those areas where we see those couple outliers, we are seeing some TCDD in it. So it's hard to tell. Again, what we're trying to do is just compare background to in zone and try and determine whether or not we can see that correlation. If we see a difference, because we have a couple higher hits in the background. I know we got one up here. It's still within normal ranges, but it's on the higher side. So if one of those higher ones that's in normal ranges but high, and one of the in the normal ranges and high here, if they're the same, then I would suggest probably not. But I haven't looked at the data that closely to know yet. So, and neither has our team. So. Yeah. Mm-hmm.
Where is, like, what are those mountains? What towns, like what locality?
Yeah.
Are we still in East Palestine
Yeah.
there? Are we crossed out East Palestine?
Good question. So the reason we don't, especially on this one, you're not going to see any features because these are the actual samples that were collected. The purple dots are the inspected and sampled. The pink dots are just inspected. The reason we don't put any features on this is we want to protect people's privacy. If somebody has a sample collected on their home, we don't want to make that public. We actually have a law now that says we can't make that public. So that's why the maps are kind of vanilla, if you will. But over here, this was just the approach. So this one has a little bit more feature on it. Here's the state line. Here's the derailment site. Negley is down here, okay, for context. All right, Negley, derailment site, 1 mile radius, high school, city park, okay? So kind of give you some context. Darlington, over in this area. Unity up here. Okay. Yeah.
Is it possible for the train cars that are running over the contaminated soils to carry them away with them, like up through New Galilee and stuff?
That's a good question. That's a good question. I don't think so mainly because on the tracks itself, it's ballast, right? It's not heavily contaminated dust or debris. Is there that potential for some low-level dust that might have some contaminants in it to migrate off-site from that? I think so. Yeah. Would it be at any level that would be of significant risk? I doubt it. Again, we're just, our dust trackers aren't seeing significant dust coming off of those areas. Now, where we are seeing dust is from our support vehicles coming off of, we have a support area up near Cardinal Welding. We are washing trucks before they come off site. So they go through the wash station, but they still go over some rock and soil. So we are seeing a lot of dust on Taggart Road. But the one thing I do want to assure you all is that those trucks, before they leave that site, are getting washed. Yes, they may be going over some dirt or debris, but it's not dirt or debris from the derailment. It's dirt or debris from the support zones. So that's important. But I wouldn't think that the trains passing through, again, because we're not seeing our dust trackers with elevated numbers. So I don't want to say no because that would be disingenuous, but I wouldn't think that there'd be any risk there.
The reason why I asked that is because last week when I was up in New Galilee, I got sicker there than I do at home, and I could smell chemicals as soon as I got out of my car.
And how far away was that from the derailment site?
Do you know how far New Galilee is? Maybe 7 miles?
7?
Yeah.
Oh, no, I wouldn't travel that far. I mean, it would break down a lot.
It's just right. We were right next to the tracks, so that's why I wondered.
I wonder what else what might have been smelling, I wouldn't think 7 miles away. I mean, we know that, when the creek gets disturbed, we were talking about this earlier. When the creek gets disturbed, every now and again you'll get some odors, right? When the excavation's going on at the rail line, the butyl acrylate odor threshold is really low, all right? It's well below health risk levels. You will smell the compounds periodically. That will happen. That's one of the reasons we worked with the railroad to set up the temporary relocation program. But in general, our air monitoring has not shown any exceedances off-site for health-based numbers. So, other questions? Yep, up here.
All right, I don't know a whole lot about chemicals either, but I went to the person that I know that does know. And what I was told was a one-time test is not enough on your property. It needs to be done more than once. And also, if I was in that vicinity where it was a little bit higher, even if it was my neighbors, I think it would be fair for me to be told so that I would take some precautions when I'm outside.
So in terms of?
Like you said, the dioxin, there was one place that was a little bit higher.
Oh, yeah. No, we'll be reaching out. So those like, again, one of the locations was near a landfill. There were no residents in the area. Another location was in a wooded area where there were no residents in the area. There was one location, it's lower, but it's high enough where we will be talking to the residents in that area. So that's a yes.
Okay,
Yeah.
I am a property owner, and I've talked to you before more than once.
Yes, we've talked.
I really had intentions of selling my home this year, and at this point, I can't do it, okay? My property's a lot to take care of.
Yeah.
And I was ready, and now it's like, okay, I have to stay here another year. I feel that my property should be tested just because I would feel more comfortable, you know, to the next person coming to my property. And it would be easier for me to sell my home.
Yeah, no, I understand. My only feedback there is, you know, I hate to say it this way, but let's wait and see what this first phase tells us, right? Let's see what the second phase might look like. Again, you know, in a perfect world, we could collect 5 samples on every property, you know, and do more of a risk-based assessment. That would take years, you know, to do it. Yeah. So I don't know what the right balance is there, you know. But your point's taken. Now, in terms of collecting samples over time, I wouldn't think that would be necessary if
As long as it's, you know, I think I understand what you're trying to do.
Yeah.
You know, keep it in vicinity and, you know, just keep checking.
Yeah.
These places, especially these higher, even the ones that were tested okay, they should at least be, you know, nearby, checked again. I mean, and again.
Yeah, I'm not sure from a technical standpoint, I'm not sure I agree, but I get your point. Now, the one piece of,
The expert told me this is the way it should be.
okay, well, feel free to send them our way. I'm happy to talk to anybody, really. I mean, we've talked to a lot of third-party scientists here, and some of them are doing really good work out here, you know, in helping some of their community members. The numbers that they're seeing are very similar to the numbers we're seeing, so we're encouraged by that, but it's independent. It's not affiliated with us. It's not affiliated with the railroad, so, and we know that's going on, so that's a good thing. One interesting piece of information, and again, I want to be careful about how I describe this because we don't have all the validated data in. I was really surprised when I saw that the Taggart Road data come in and areas south, all that data is coming in really low. I thought really low. Oh, okay, but I'm just saying that I just thought, you know, based on the wind patterns and everything we knew about the derailment site and what people like Eric that were on site early on told us.
But did this happen the night of the accident? Because the wind was coming our way.
Right, it was all over the place, right, Eric? It was all over the place. Yeah, we've heard that. Yeah, and that's why we did a whole mile around, because we knew that. Yeah. So, anyways, another question, sir.
Yeah, this area here, a lot of people grow gardens and things like that. What's your recommendation for doing so this year?
Yeah, I'm glad you asked that because that was actually part of my talking points. I never said anything. Our recommendation is to continue using your properties the way you normally would. We actually just had a meeting with the garden club, one of the garden clubs in the area, Tuesday night, and we had an expert come in, a phytoremediation expert. You know, phytoremediation is using plants to clean up, chemicals. He told us that the chemicals that we're dealing with, if they were a problem, do not readily they do not readily uptake into those plants. So even if we had a problem, he doesn't believe that, you know, you should not garden or farm. Okay, that was his piece of advice. Our recommendation to date, because of the analysis that we did, the modeling and analysis that we did, and how we understand the chemistry of the vinyl chloride burn, we don't believe that there was enough dioxin concentration in that smoke to create a problem. Okay, the back calculation that we did, and it gets to another question one of you guys asked about the modeling. We back calculate. I think you asked it. We did the modeling for the one car the night before the vent and burn. We did an event reconstruction model several weeks later to look back at what the 5-car burn did, plus the observations from our guys on the ground, you know, plus the wind patterns that we looked at from various sources.
Were those released to the public?
Not yet. They give that to us as what they call it, 4 official use documents. We have asked them for a releasable form of that. So that's a goal of ours to get that in the public's hands. So stay tuned on that. Back to your question. So part of that analysis was to evaluate the dioxin concentration in that plume. And the calculation that they gave us was that there were 44 grams of dioxin, roughly, it's an estimate, created in a worst case scenario, assuming 90% of that 900,000 pound burn combusted. 44 grams over probably 50 square miles of, of area, that's nothing. And that's not appreciable. So that's one of the reasons we have maintained since the beginning that unless you're right along the creek, right there in the creek, or at the derailment site, use your property as you normally would. And if we get data that says something should change, then don't do it. But right now, everything's trending in the direction of that. So, yeah. Oh, no, that's a technique. Phytoremediation is a technique, yeah. This expert was he is like a limited liability company now. His name is Steve Rock. Steve Rock, yeah.
Does the vinyl chloride come out of the soil just like the butyl alcohol?
So vinyl chloride is actually more volatile than butyl acrylate.
Okay.
So when it gets into the sunlight, it's going to break down pretty quickly. But yeah, it's volatile. Both compounds are volatile organics.
I'm asking,
Yeah.
when you're digging up over the tracks,
Yes.
only being active we use.
No, vinyl chloride, and so vinyl chloride's our driver. Butyl acrylate smells really bad and is an irritant. Vinyl chloride is a cancer-causing agent. So our sampling is really geared towards making sure that there are no appreciable vinyl chloride exposures in the neighborhood. That's our driver. Yeah.
And just for awareness, it's right after 7 o'clock. I know we had a permission from 6 to 7 o'clock, so we have time for a few last questions. And also, we want to invite anybody that may have questions also regarding the instruments and equipment that we're using to please ask it to the personnel that we have here if you'd like to ask some questions. Any additional questions right now?
Yeah. Oh, John. Yeah. Oh, good. Excellent. Thanks for bringing that up. So, and welcome, John. So our friend from USDA. USDA in coordination with Ohio Department of Agriculture and the Farm Bureau and Extension have developed a program for sampling plant tissue. So they've gone out to, Haley, is it 16 locations? Correct. Yeah, 16 locations, some of the same locations that we collected samples on, and collected plant tissue samples for analysis. So, if the soil sample data all comes back looking good, if the plant tissue data all comes back looking good, that's just more confidence that we have in the overall, evaluation of gardening and farming. To your question, thanks for that, John. Appreciate that. Yeah, so that's being done. I don't know when do we think data will be back? About 3 weeks, but for the initial data from the plant tissue sampling. So, yeah.
One more question over here.
Yeah.
So with them digging this soil up, you're saying the butyl acrylates are probably what's making people sick, and the vinyl chloride is a carcinogen. So if people are showing no symptoms, they can still be exposed to the vinyl chloride?
So vinyl chloride doesn't smell, okay? Or if it does smell, it's very mild. Okay, so you could potentially be exposed to vinyl chloride and not know it. Yes, that is accurate. However, we have analytical equipment. We have air monitoring devices that are very sensitive to vinyl chloride. And we have that bus you see driving around the neighborhoods doing real-time analysis. Anytime digging's going on, all that work's happening. And some of the samples we're collecting are 24-hour samples. So we're able to give you what we call a time-weighted average of analytical work to better define risk, okay? And right now in the neighborhoods, we're not seeing anything anywhere close to.
How are people testing bottles?
Yeah, well, like I said earlier, you have the source of contamination, which we know where it is, train derailment in rivers, and we have illness, right? We don't have an exposure pathway. If we had an exposure pathway, I could tell you, but that's what makes this really hard, right? It's, we need an exposure pathway to be able to advise on whether or not it's the chemicals from train derailment affecting people's health. We don't see that connection. We don't see it, we don't see it in the soil right now. We don't see it in the air right now. That's a really hard thing for us to talk about because we understand that some people are hurting. And
If you're seeing it in the urine, I don't understand how you can say people aren't being exposed.
and that's why I recommend checking with that health clinic if there's some epidemiology that comes out of all of these cases that suggests there is a common source, whether it's a train derailment or something else, that might help. Like I said, we can't take action if we don't know what the exposure pathway is.
When are we gonna hear from the CDC?
I don't know.
Because I feel like
Yeah.
what they're saying is if you're sick, you're actively being exposed to this, to go to the clinic. And the longer we're exposed to it, we need to stop the exposure. We don't need to go to the clinic.
Yeah, and that's what makes this hard because I don't know where you would be getting exposed. That's the problem. We're not seeing it in the air, we're not seeing it in the water, and we're not seeing it in the soil, other than those contaminated areas. So, yeah, that's what makes this hard.
So Mark, I think that what we're struggling with, and maybe we can clear this up a little bit, and I said before, say it again, one phrase, 5 vinyl chloride cars. How many gallons? 90?
900,000 pounds.
Yeah, 900,000 pounds, which gallons is millions and millions of gallons.
I don't know the conversion rate.
So if you take that and you burn it, and it goes, and disappears, how can it not be, how, the chemistry behind it, how did it just disappear? How did that plume not go out and then fall down?
So,
I can see town maybe not being so
Yeah.
contaminated, because the plume went up, it got carried away, and then dropped. But where did they go? How can there be nothing? That doesn't even, but yet you're telling us a campfire would create the dioxins, but something of this magnitude would not.
Yeah.
That doesn't make sense.
yeah, I understand what you're saying, and for me, when I put on my problem-solving hat, I don't look at the dioxins as a problem because the science just doesn't support it. Okay, but right, and that's where I was going with. That's where I was going with this, Linda. So, and I think, all right, what else could there be? What else could have been created? And all the volatile organics, the sun will break that down quickly, right? You won't see vinyl chloride, especially down where you live, in the air plume, right? But what you might see are some breakdown products. Hydrogen chloride, like I said earlier. I would not be surprised if people that had, irritation effects that were exposed to smoke, I wouldn't be surprised if they were exposed to low-level hydrogen chloride. That wouldn't surprise me at all. The monitoring that we did on site, I don't know if you guys saw any hydrogen chloride on site, Eric, when you, that night, but the plume went up and then out. So we wouldn't see it on site because that's not where it went, right? So, exactly. So if there were some short-term effects, that wouldn't surprise me. Long-term effects, again, when I put that, that sleuth hat on and I'm trying to solve that problem, I just don't see where it could have come from, right? Or where it could be, and I don't want to discount it, right?
How did it go? You're saying that the sunlight would have caused it to just...
Yes, sunlight will break down, the volatile organics, right, quickly. And anything attached to small particles, would be, again, broken down quickly. Right. Eventually, it's going to break down. I mean, it breaks down, especially when your particles are down around 0.1 milligrams per, square meter. Again, it's just hard for me to see where that long-term health effects would come from. If we had the answers, believe me, I'd be giving you the answers. I just don't know what to tell you there, Linda. So anyways, really appreciate you guys coming out on a nice night. Yeah, and again, we'll hang around for a bit if you're interested in some of the equipment. I'll hang out if you guys want to talk tech one-on-one. I'm happy to do that. So appreciate you guys.
Yeah, thank you everybody for coming, and thank you to the way station and to the church as well for inviting us and allowing us to have this meeting here tonight. So thank you very much for that. Have a good night. Thank you.